this unit, we will study about mesh network. Last time we considered the nodal analysis. In mesh analysis, provides another procedures for analyzing a circuit using the mesh current. The variable in this is mesh current. In nodal analysis, we use KCL, and mesh analysis we use KVL. So mesh is a loop which does not contain any other loops within it.
which is as the same.
So the structure is same, but we have to create n number of meshes.
The main
Then we apply-
variable is
because we have to apply
important thing. The
KVL.
main variable is node
Then we
voltage.
apply
Okay,
results, the
main variable is
solve the resulting
voltage.
and simultaneous equation.
Let's see.
Get the
So what is the
mesh.
current? What is the way steps to determine the node voltages? First we assign the select the reference
We
node.
have two loops.
Then
So
we
if
assign
loop one
the
current is
voltages
moving from
V1, V2,
So what is, when you say when you stay
remaining
on
nodes,
the loop one,
so we assign the
current
voltages
across
on n
this
minus
one,
1 remaining nodes,
you must have
and the voltages
direction
are
of this direction,
referred
the
with
current of
respect to
the
the
distance.
reference
This
node.
distance. What is
In
that?
nodal
Resistance
analysis,
at I3,
apply
I3 is the
KCL
I1
to all
minus I2.
n
This one,
minus
because I3
1
is in the
node.
direction of I1, so I1 minus
Non-reference
I2
node. N minus 1 is
equal
non-reference
to
node.
I3.
Only 1 is the reference node.
Okay,
So we apply Ohm's law
we can say
expression
that
and we
minus
calculate the
15
we apply the KCL on n
plus
minus
minus
1 non-reference nodes. Then we apply the simultaneous equation. Let's see the question. Example.
plus minus
This is, let's suppose we say we name it I1. This position we name it V2.
minus
Okay.
15
So this is the
plus
node
minus
V1.
I. This one is plus
the node.
minus.
So
Basically the
what do we
10
do?
ohm, but the current across it
We
is
take,
the
like,
direction
we
of
say that
I3 is similar to
the
I1, so we
entering
can
I-
say I1 minus
We say that
I2.
I
And the voltage is plus 10.
entering
We have
equal to
so we have
I.
minus 15. I repeat again, minus 15 plus 5i plus 10 I1
So
minus
those
I2
who
plus
enter
10
in the node,
to 0.
this node,
So we can, if we
and
solve
equal
this,
to the
we
those
have
who
3i
left
minus
from this
2i
node.
equal to 1.
You must have to
Similarly,
define the
second
direction
case,
of the
we
current.
have
Very important.
minus 10.
So
And this time
here we can we see
up,
that.
and
So what are the
we can
nodes?
say
Let's
that
suppose we apply
the
at node
current
1.
of this loop is
Which
I2
are
minus
the
I1,
nodes
because this is your choice.
is
Because the choice
coming
is yours.
inside
That, as you know that the
the
direction of
node
I3 is
1.
opposite to the direction of
So
I2.
we can say that,
there are two.
let's say
because
this is
this
I1.
The loop is flowing in this direction. So this is a negative.
And we can say
negative
that
because the direction is negative. to
this is
direction.
I3.
So there's two methods. Normally, what is the easy method? When
This
you
is
solving this side, so you say I1 minus I2.
Okay.
When you solving this side, is you say
So
I2 minus
in
I1.
5
Otherwise,
ampere is
what you have to
entering,
solve, when you solve
so
this
5
one, you have to calculate
equal to
minus 10 I1.
Yeah, or you can
minus
say
I2,
I1
because the
equal
current
to
I1,
the
I3 is
I2 and I3.
I3
Because
is
these are
I1 minus
together.
I2.
You can say
I3 is
I1
I1 minus
equal
I2.
to
But the
I2
direction is
plus
negative
I3.
according to the I2. This is why. So in this loop,
How
the
to
direction is
calculate I2?
opposite to this loop.
For
So this is
calculation of
why we
I2,
use
we can
minus.
say that
So the easy way to
V1
handle this, what we say when you
minus
solve this
V2
mesh, just use
divide by
I2
the
minus
voltage.
I1. When you
You
solve
can say
this
that
mesh,
voltage drop across this
KVL, then you
distance
say I1 minus
divided by
I2.
the resistance
Okay, when you solve the mesh
is
2, so
equal
we
to
have
I2.
minus
You can say that
10, we have
I2
minus,
is
we
equals to
just, we can say
voltage
I,
across
I2 minus
4
I1 plus
divided
I2
by
minus
4.
I1
So voltage across the 4
into
ohm
plus
is
I2 minus I1 into
minus
10 ohm.
V2
Then we have plus
when we
minus,
say that
we
the
have
V1
6
minus V2,
ohm.
this means that
We have 6
the
ohm.
current
We
is
can
saving from
I1
I1 toward
V2
V2.
into 6 and I2 into 4.
So this is
So
become
we have solve this becomes
I2 is
because we
equals
have
to
two
V1
I1 and I2 two variables here. So we
the
also
reference
require
node, you know
two
what
unknowns.
the reference
When we have two unknowns, again we have
V1
used the Cramer's rule,
minus
and
0
when you have to use
divided by
Cramer's
2
rule and calculate the
by
delta,
3.
delta 1, delta 2, and then we calculate delta 1,
equation
delta
becomes
2,
I1
I1
is
have
5
I1
ampere.
and I2. So in this
I2
way,
is
it is the way to solve it. I just
plus
want to repeat the same
I3
things
is
for the
V1
revision. How we
minus
do it?
0.
As we already discussed with nodal
So,
analysis, that how to solve Cramer's
we
rule.
have
Just
to
repeat
solve
again.
this equation. Let's
So we
see.
have the constants 3 minus 2 is LCM. So we can have currently we is like this minus I1 plus 2 I2 equal to 1. So this is minus 1 plus 2 equal to I1 here.
this I1 is this one. So minus I1 plus, so we have minus 1 and minus 2. So again I will repeat it again, that the matrix becomes 3 minus 2, second row minus 1 and plus 2. The right side becomes 1 and 1. We can say that the variables is I1, I2. Which are the entering nodes? So what we have to do, we have to take the, this is entering node, this is determinant of this matrix to become calculate delta. Determinant of this matrix is 3 to 2, 6. So and minus minus plus is we can 2 say, and the sign between is minus. So it becomes 6 minus 2 is 4. So the delta 1 is minus. So we have to calculate delta 1. We have to replace this one with the column 1. So becomes delta 1. So the determinant of this will become delta 1. So 1 to 2 minus minus plus on the 2 on the 2 side 4. So 2 on the 2 becomes 2 plus 2 is 4. So delta 2, for delta 2 we replace this column 2. So this becomes 3, 1 so 3 minus minus plus and 1 is the 1 and 1 and becomes 4. So 4 divided by 4, 4 divided by 4 becomes 1, 4 divided by 4 becomes 4 minus 1. Both have 1 ampere. Similarly, now we have another question that if we have 3 variables, you can see that we have 3 variables plus 40. Here the question is basically this is the independent source, this is the dependent source. So when we have this cases, so we have minus 24. Then again I told you it's easy way, then when you solve this one, you say that I1 minus I2. But actually the current, actual current of I0, remember that I0 is basically current is in direction of I1, so we can say I1 minus I2. Okay, so the current is I1 minus I2, but actually when you're solving the mesh, it's very easy. Just use it like 10, I1 minus I2 into 10, and here I1 minus I3 is equal to 12. So we have this one equal to 0. When we solve this side, mesh 2, so we have 4, that we have 4 minus I3, and you can say I2 minus I3 into 4 ohms. This side I2 minus I1 is 10 ohm plus, and also we have I2 into 24 ohms, all are plus. So similarly here we have I3 minus I1 into 12, then here we have I3 minus I2 into 4 plus, and also the plus 4V I0 and 4 I0, and the I0 is already defined as I1 into I2, so we can say equal to 60. That we have I0 is I1 minus I2. So we have currently how many equations? We have one equation, variables. We have two equations. We have another equation is unknown. We have equation variable 3. We already have. So we must have matrix. This is the 3 equations, 3 constants, have 2 equations, the variables and the principles of the variables. So as we know, I'll just repeat again. You can use substitution 11 minus 5 minus 6, 11 minus 5 minus 5 minus 6 equal to 12. Equal to 12. Then we have the next one. We have minus 1. Then we have minus 5, 19 minus 2. Minus 5 19 minus 2 equal to 0. And then we have the equation becomes minus 1 plus 2 minus 5 minus 1 plus 2 equal to 0. The variables I1, I2, I3 is 60. There are 2 methods that the last time as we do, we can use the determinant to calculate this one. Also we can have an option to calculate determinant in by this way. What we do, we just repeat the first 2 rows again as we see here, and we multiply all this one on the right side. When we cut it on the right side, we multiply and the sign is plus. We multiply with the plus 1. If we on the right side, we multiply with minus 1 and add all the answers. So we have this answer. This of determinant is also easy technique. It's very easy to calculate this way for 3 by 3. So we have delta. First we have to calculate delta. Then we have to replace this one. We calculate delta 1. This is delta. When we replace this one, the determinant is delta 1. When we replace this one, becomes delta 2. When we replace this one, becomes delta 3. So delta 3 divided by delta 1 divided by delta is I1. We replace the delta 2 divided by delta is I2, and delta 3 divided by delta is I3. Replace this